Good morning, students. Today we are going to discuss about uninformed searching techniques present in Unit 1. So, for evaluating any search strategies, we have some parameters. We should have to aware that technique will reach the completeness for the solution, and how much of time it will take to reach from source to destination, and how many number of nodes it will be expanded. For coming to the space complexity, when you reach from source to goal destination, how many number of nodes you have to pass, and we have to also find out when you pass from source to destination how much of minimum cost it will be take and to provide the solution. So when coming to discuss about what is uninformed and uninformed search strategies, uninformed itself, in the name itself we come to know it's a blind search. It does not have any directions to reach to the goal state. Examples for that example for the type of searching mechanisms are BFS, breadth first search, depth first search, and depth limited, uniform cost, iterative mechanisms, and bidirectional mechanisms. These are the some examples for uninformed search strategies. Today's class we have discussed that how each and every uninformed search in detail, what's the performance of each and every algorithm. Let us discuss in the coming slides. So come to the informed searching strategies. Here it follows some heuristic mechanisms. When you want to retrieve any information regarding to reach to the goal state, it will provide that information, and especially it reduces the cost and provides the optimal solutions. Coming to the informed search strategies, the examples for that is hill climbing, best first search, greedy mechanisms, and A-star algorithms. That in detail we are going to see in the next class. What are the informed search strategies? So when coming to illustrate uninformed search strategies, here let us consider an example. It is a graph where S is the source node or initial state which is going to reach to the goal state G. Here S is the source and G is the destinations. When coming to the in detail, I am not in depth I am going to tell. It's just simple words I will tell in which way the breadth first search mechanism follows. Now it's a first in first out order mechanism. It's also providing best solution because it must be long, and it's provide shorter length first, means it's a best one of the best algorithm. So when coming to the depth first search, second uninformed searching strategy follows last in first out mechanisms. Here we followed the depth bound mechanisms, the cutoff search below fixed the depth. When we are going to hits the dead end, it having the opportunities to back up and find out that particular node. And uniform cost is a branch and bound mechanisms which follows Digistress mechanisms. All you people knows under Digistress algorithm we consider the minimum cost to reach to source from destination, optimal solution. So it is nothing but optimal solution we are expecting in this algorithm. So same iterative is a combination of both depth first and breadth first, and considering the advantages. So the time complexity is worse in both BFS and DSS. That problem should be overcome under depth first iterating. Same, let us we see with the examples, then we clearly understand. So how depth first search, breadth first search. Under breadth first search we have to traverse the node from source to goal. We have to search that graph level by level only. So here in that mechanism only we followed from S, A, B, D are the siblings, and from A, so again we have to traverse B, C, and then only we move to D, E, G. And if you consider B, again we have to move from C, D, E, G, and if you consider from D, it is again E, G, and then only it will be move back move to the goal state. So how was the possibilities for the goal state? So like E also like that only, for G also like that only we have followed. That means the mechanism is completely followed breadth-wise searching technique. So here when you coming to the depth first, we have going to search the things from S, A, B, C, and from A, if you are going to states, it concentrate on depth first, and then only it will be moved to the breadth. So A, D, D and E and G, and then only it will be moved to B and C. When coming to B, so again same thing, it comes to E, and then it comes to, when coming to B, D it will be considered so D is considered E, G and then B, C. If then coming to, again coming to E, E means we consider G and then B and then C. Like that it is performing the find the solution path. In uniform cost, same mechanism we followed, but here in uniform cost, minimum cost. So if you are observing the graph, so S, A, B, C, which one having the minimum cost? B. That it will be considered first, and the next minimum cost it's A, and then it will consider A, and then C, the same, and then C. The same mechanism is followed, and it find the minimum optimal solution. So compared how they perform when coming to breadth first search, depth first search, uniform. When I observed uniform cost, it's under uninformed search strategies, which algorithm worries about costness, that uniform cost search only. And coming to the iterative deep searching, is also same like, but it's having repeated way of searching. It's also somewhat difficult to iterate from source to destination. But coming to bidirectional search is having an advantage. It travels in both direction, from source to goal and goal to start. So by having this advantage, the time should be reduced. The searching time complexity should be reduced by half. That's why we have to consider D by 2, depth by 2. And then when we comparing the searching strategies, breadth first, uniform search, depth first, and are all having B power D, but when coming to bidirectional, it's reducing the half of the cost, and if in space also same thing, it reduces half of the cost. And when coming to the optimal solution, so best one is uniform cost approach. And when coming to bidirectional also, so if half of the time is reduced, means the cost also minimized when you search from source to the goal state. So these are some of the comparison, these are the some of the parameters which we compared for the existing uninformed search strategies. Thank you students for your patience. In the next class we will discuss what are the informed searching strategies, what is heuristic functions, and what are the advantages of informed search strategies when coming to when compared to uninformed search strategies. Once again thank you. So be thorough for these concepts, again revise it with new examples and practice a lot. Thank you students, thank you very much.